Oh, okay. I originally put this down as a workshop, and there's more material, a lot more material than we're going to do in 20 minutes. But I thought, well, rather than just make a load of slides, I can distribute it to you guys and you can look at some code. So anybody used Jupyter before or not? Okay, it's IPython 3, and what happened was the Julia guys who were at MIT went over to Berkeley and they knocked up IPython 4, and in a week they wrote a kernel. So in fact it's now called Jupyter. Ju for Julia, Pi for Python, and R for R. Although nobody ever actually uses R because R Studio's pretty good. But actually there's a whole load of kernels, including Perl and Perl 6. So I don't know if I can show this. Let's have a look. New notebook. Oh, there you go. Okay, so you can see the kernels I've got here. I had it a minute ago. New notebook. I got Bash, iPerl, 4 flavors of Julia, Octave's a MATLAB clone, Python 2, Python 3, and R. But there's Haskell, and there's about 60 kernels now. So, okay. So what I want to do is it does HTML using a thing called Markdown, which if you use GitHub you'll know. So what I want to do is actually just tell you how, if you get a copy of this, I'll zip it all up, then you can run it yourself. Okay, and in fact, at the top here, although I will put a README, I've sort of said you need to install Python and Jupyter, or you can just install Julia, and you can build it from there. Okay. Right, so, title of the thing is Julia and Perl's Strange Bedfellows, which is actually a misquote from Shakespeare's The Tempest. And all the best quotes come from Shakespeare, don't they? So, and just a quick thing about me. Okay, I've been programming a long time. My research work was in Fortran. My first job was COBOL, and I had a look at Pascal for a day and then gave up. In '95, we started working in Perl, so that now turns out to be quite a long time ago. And in fact, we started on quite big projects, but then when the web came, Perl was king for a while with CGI, so we did CGI. Now we tend to use it more for sysadmin. Now I've taught a few things and I've worked a few places. The interesting thing is that at present, we worked out we actually use or have used over 20 different languages. If, as consultants or contractors, somebody says, can you use this particular language, we always have a 3-letter answer rather than a 2-letter answer, which means we have a couple of weeks to learn the language. But I currently use C, Julia, and Perl, and what I'd like to do is tell you why that's the case. The quick thing, though, is there's Julia and the snake. It's interesting how long some of these things have been around. These numbers are when you as a person could first get your hands on them. So Python's been around for an awful long time, 91. In fact, Python 3, anybody use Python? No? All right. Python 3 has been around since 2008. And okay. Octave is, say, a MATLAB clone. R is a S+ clone. Ruby, Haskell, Scala. Perl 6, I don't know if I'm giving that justice, but that's when you could first get your, I think it was called Parrot, wasn't it, originally?
Parrot was a virtual machine that you could run Perl 6 on.
Okay, but that must have been about then, because I think the actual Perl 6 was proposed in about 2000.
Well, Perl 6 isn't a language.
Well, all right, well, fair enough.
It's a language specification.
Well, I downloaded something that runs scripts. Rust and Go, Clojure. So Julia is actually quite young, 2012, which makes it 21 years younger than Python. So a quick thing about the timeline So I say, but it began in 2010, but it wasn't open source till 2012. There were some Google Summer of Code projects in 2014. I think Julia was up to about 0.3, 0.4 then. I wrote a book around then, which I'm now revising because Julia's moved on a lot. My book hasn't. They formed a commercial wing in 2015, which is now, still gives the stuff away, but it's trying to do like Red Hat and actually make money out of enterprise services. I'm doing quite well actually. It's raised about $5 or $6 million. Still not 1.0, but that's in alpha. The beta should be out by Christmas, and then we're hoping that the actual release candidates will be out by next Easter. And JuliaCon, which is the annual conference next year, is in London. So I've got a slide for anybody who wants to go to JuliaCon. And here they all work. If you get the notepads, these are all the sources on here. Julia Lang is the community. Julia Computing is the enterprise version. Okay, so when I say everyone, that's probably just me. Julia's quick. So why is it quick? Well, here, this is a log scale, by the way. Okay, and this is Julia. Set of benchmarks, and you can see Julia's nicely clustered. C isn't there because C uses the baseline. So Fortran's a little bit quicker for some of these tests. Go, JavaScript's the V8 engine. Python, 15 to 30 times slower. Mathematica, R is really slow. MATLAB, obviously things like these two tests for Mathematica and MATLAB, well, they're actually random multiplying matrices, which is done in C. So it's not surprising that MATLAB's quick at that. And then Octave is really slow. So you could actually be running something which is 1,000 times slower than running it in Julia. So why? Well, the reason why is because Julia compiles the script. So you start off with your script. It turns it into a tree, and then it goes through various stages and produces what's known as LLVM. And that's okay, all right. And in fact, this uses LLVM. My phone over there, because they're both Apple products. The guy who did this was a guy called Chris Latner. He was at Illinois, Urbana campaign, and he got a master's course for that. That's it. It's very hard to get a doctorate in America. However, he also became chief designer for Apple, and that's why this uses it. The idea at the time was to say, well, why, rather than keep writing compilers for different machines, why don't we write one compiler down to some sort of intermediate code, a bit like Java or .NET, and then all you really have to do for your particular architecture is to just write the LLVM to machine language. Okay, so you can have the one tree and then all the different versions will do it. The Julia big idea was to incorporate it into the build process. So that means that you start with the code and you finish up with native code. Okay. Now, for the book, I decided I'd run my own baseline. This is a well-known problem. I won't go through it because you can read. But the idea is to work out the sum of 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared, etc. It took 90 years before Euler found out that it was pi squared on 6. And it converges quite slowly. So it's actually quite interesting because it's not the kind of thing where you're looking at back-end C routines. The code's easy, and I've got a few timings here. So in Python it took 2.8 seconds, R took 5.8, Octave took 29. This is Common Lisp compiled, which took 8 seconds. Fortran, which is also compiled, took 56 microseconds. That's using double precision. It was a bit quicker, but not as accurate. C took 39, and Julia took, what does it look? Julia took 48. So Julia's in the same sort of range as C and Fortran. Oh, Perl is more like Python in terms of its speed. So it's about benchmark that I've run, and it gives you some idea why. Now, I'm going to go through the code, but I'm not actually going to explain it, otherwise I always find once you hit code, but I will show what's in the notebook. Okay, and then I'll go to the final things. Okay, so why learn Julia? This is the last slide before the code. This is from a developer's point of view. So Julia's written in Julia, right? And it's all available. You can have a look at it. When I say almost, well, there's a little bit of glue to call to different operating systems, which runs as a shared library or a DLL, but you don't need that. So you can actually look on GitHub at Julia, which means you can, and it's well written. It can interface with lots of languages, and then it uses some quite novel features. From Perl's point of view, it's got a powerful multitasking interface, and there's a lot of things. So from a developer's point of view, if you like looking at code, you can find it all in Julia. Right, so what's in the demo? Okay, so what I've done here, this is straight Julia, define a function, call it. You can also call library things, so this actually calls the clock function from libc. I might even run that just to prove it's a live demo. So if I do that, the number should change. Okay, so that's the current tick on this clock here. It's also very good at calling Python. It inputs numpy random, generates a random number in Python, returns the array to Julia, and actually the slice, which has got no overhead. So regardless of how big the array is, you can take a slice of that without any immediate overhead. You can also use Python as a wrapper to do things like plotting graphs, and there's a whole load. Gadfly is ggplot. Anybody who's into ggplot2, that's the Julia implementation. So you can actually call this is matplotlib with pyplot as a wrapper to produce a nice little curve. Okay, this is the actual code for the Basal function. You give me a Y5 and then I'll jump to the bottom. This is the curve for the Basal function, and this is the timer, and then actually you can, that little at means it's a macro. You can expand it to look at what the macro code is. So essentially what it's doing is puts this block code in, which really just defines 3 local variables to work out the garbage collection time, the actual time, and then it works out the elapsed time, and then it prints it all out. So at time, you can see all the code. So here's, the other thing is you can actually see up here, it tells you where these lines are, and you can actually go and you can find the code on disk, because all the sources there. Okay. Now what I'm going to do is, because we've not got that long, I'm just going to say what about Julia and Perl, since you guys are interested in Perl. Julia has regular expressions. There are special strings with an R in front. It has pattern matches, but it's not actually built into the kernel, so you actually have to use a package. And the string handling is relatively slow. I mean, it's slow compared with Perl. It's fast compared with Python and other things, but it's slow compared with Perl. So Julia's I/O is quick. It uses Giant's Node.js library, libuv, but there is no direct interface between Julia and Perl yet. There is between Java, R, and Python. So actually, you have to rely on multitasking. And so I've got some demonstrative things here, which Perl one-liners. So this one actually works out all the palindromes that are greater than 5 from the words dick. Okay. It creates an object. The backticks used to run in Julia, and now it creates an object of type command, and then you have to run that to actually execute it. The other thing actually I should say about Julia is all the help's online as well, because you can define the help as part of the module, so you can see all the commands here. And detach is interesting because that means you can run a command and leave it running and carry on. So you can run asynchronously just by setting the detach flag to true. Okay, so I've got a thing here which is, if you actually want to run Julia with Perl, you have to run it through a pipeline. So this is one where we're actually catting this cat and through itself to show. So you run it through a pipeline that comes through. There is a problem with this, and I'm probably not going to get to tell you much about it, and that is that it doesn't actually, it writes to standard output. So you cannot just capture what the output of this straight into a variable. Okay, there's a few ways around this, and I'll talk about it quickly in a minute. You can write to a temporary file and then read the file, and there it is. But there are some other methods which allows you to run pipes and capture into things. Now, well, I've got about 5 minutes, 2 minutes. Wow. Okay, I have to be quick. Okay, so we're actually talking about process-to-process communication. So there are quite a lot of things to do. You can write to disk. You can write to a database. It supports, if you want in-memory databases, Redis, Lightning DB. What's the other? Memcache. You can capture standard I/O. These are all a little bit more development. It supports shared memory. Messaging works because that's the way Jupyter works, and it supports sockets. So since Perl can support that, then you could run a Perl program detached, and you could message between the program and the Julia. Okay, I'm going to jump, because I've only got 1 minute, to my finishing slide, which is here. These are my conclusions. As I say, if you want to download the code, I'll zip it up with all the images and scripts and a README file to get you going. Okay, so I like Julia because I can look at the code. Okay, and I like looking at code, and it's all there. Not just Julia, but all the packages. I don't believe what one person can do, another person can emulate, so I don't actually think execution speed is the main thing. The big one is because it was only designed 5 years ago, a lot of other stuff's been put into Julia, which is hard to retrofit. Okay, just finished, and a lot of the current work is on machine code. Big thing is, I say, JuliaCon's in London next year. So it's at University College, just across the road, from the 7th of August. And because of that, this is the Julia user group, and in conjunction with Julia Computing UK, we're going to be doing a series of courses, probably from about February. Okay, that's it. Right. Okay. Anybody? Yep.
You guys using Julia in production?
Yeah, what happens is Julia Computing, these are some products from Julia Computing, they're doing quite a lot of work. They're doing some work over here in the UK for Aviva. So, if you actually look at the Julia Computing site, they give you a whole list of all the wonderful things they've been doing, you see. So, Julia Pro is the version, which is a kind of bundled version, which is quite nice because you get all the packages without having to install them, a bit like Anaconda for Python. But Julia Computing are doing, I think the finance people pay quickly and on time, so it's a good way to raise money. And then Julia Run, this is actually one of the guys in Bangalore, is a batch version. So it is being used in. Okay. Yeah. Well, yeah. Well, there is. I mean, it's a question of somebody doing the work. One of the original three guys, Stefan Klisk, is a Perl. We call them hackers in my day, so I know you all call them mungers now. And he's going to be over here for JuliaCon. So yeah, I mean, I think there is, and there's a couple of ways. You can actually look at the interface, say, with Python, and look at the interface perhaps with Java is a JNI wrapper, and R, it just actually installs, which you could do the same, it actually installs an interpreter. But yeah, I mean, there is, and I think there's a good thing to actually think of doing some work, proper messaging between the two, rather than run. But the pipeline, if you're running it on Linux or on OS X, it's pretty quick, actually. So, yeah.
Thank you very much.
Thanks.